Hi there! In this video, we are going to discuss the cocktail shaker sort algorithm. If you haven't already done so, please check out the bubble sort solution video, as it is a prerequisite for understanding cocktail shaker sort. Cocktail sort is a variation of bubble sort, and it has some interesting optimizations. So today we'll walk through how it works, we'll write out the code step by step, and then we will analyze its performance using Big O notation. By the end of this video, you'll understand how the cocktail shaker sort differs from bubble sort and how it can be an efficient alternative in certain scenarios. Where does the name cocktail shaker sort come from? The algorithm gets its name because it works like shaking a cocktail. It moves the largest element to the end in one direction and then the smallest element to the start in the other direction. So that back and forth movement is where the name cocktail shaker comes from. It's also referred to as just cocktail sort or bidirectional bubble sort. As I mentioned before, cocktail sort is an extension of bubble sort. It sorts in both directions, first from the left to the right, and then it goes back from right to left. So this alternating pass of back and forth reduces the number of comparisons and swaps that are needed through each pass or iteration. Let's take a look at an array and see how this actually works. So we have the starting array at the top, and you can see that the first pass forward is going to be from left to right, moving the largest element to the end. So in this case, the number 9 was moved to the end. Rather than starting again at the beginning, it's going to turn around, reverse directions, and move the smallest element back to the start of the array. So that second pass is going to move 2 down to the starting index. One full iteration will consist of the pass forward up the array from left to right and the pass back down from right to left. Here we have a larger unsorted array. So as you see this played at speed, you'll notice that the larger elements are being sorted on the right of the array, and the smaller elements are being sorted to the left of the array. Let's take a look. On this first pass forward, the largest element is going up to the right of the array, and now the smallest element is filtering down to the left side. Now the larger back up to the right, and the smallest back down to the left. This continues for the unsorted parts of the array until the entire array is sorted. Let's visualize what this swapping looks like. So here we have an unsorted array with number 19, then 48, 112, 93, 87, and 39. We are going to start in the normal bubble sort fashion, going from left to right. So our first comparison will be 19 and 48. 19 and 48 are already in the correct order, so we will move on to the next comparison of 48 to 112. These are also in the correct order, with 112 being on the right side, so we'll move on to 93. 112 is larger than 93, so we'll need to make a swap here. Next, we're going to compare 112 to 87, and 112 will bubble up to the end of the array, and there will be a swap. The last comparison will be 112 to 39, so 112 will bubble up to the end of the array and be in its final spot. Now, rather than going back to the start of the array, we will reverse directions and start with 39. And now what we're looking for is the smallest number. So between 39 and 87, 39 is smaller, so we want to swap those two and move 39 down towards the beginning of the array. Next, we'll compare 39 to 93, and again, swap as 39 moves lower in the array. We now compare 39 and 48 and make another swap. And the final comparison is 39 to 19, which we find are in the correct order. So number 19 and index 0 is now sorted properly, and we head back up the array for comparisons. We compare 39 to 48, and there's no swapping. Next, we compare 48 to 93. Again, no swap. Next, we compare 93 and 87, and a swap is required here. And now 93 is sorted. We'll go back down the array, comparing 87 to 48. They're in the correct order, so we'll move on to the next comparison. We look at 39 and 48. They're also in the correct order, which means no swaps are made and our array is completely sorted. Now that we understand how the algorithm works, let's create our function and write out the pseudocode. So we'll create a function and we'll call it cocktail sort, and we're going to pass in items as an array. And now I'm going to paste in the pseudocode and we'll walk through it. So the first thing we want to do at the top is get the length of the array. We'll set that as a variable so we can use that below in our loops. And we're also going to create a variable that will track whether or not swaps have been made. The next part of our code will create a while loop that's going to keep us in the code while swaps are being made, and then below we'll exit out of that once the array is sorted and there are no longer any swaps. So once we're in the while loop, we want to reset that variable we initialized to true, and we want to set that to false to indicate that there are no swaps to begin with. Then we're creating our for loop that will pass from left to right, looking for the largest element. We're looking at the adjacent pairs, and we're seeing if element I is greater than I plus 1. And if it is, we need to switch that order and swap the adjacent elements. We will then reset our flag to indicate true, yes, a swap did occur. And if no swaps occurred, then we know the array is already sorted, which means we can exit the loop. Otherwise, we'll reset the flag for the next pass. We have another for loop below, right here, that's going to reverse the order and move us from right to left, looking for the smallest element. So now we'll compare element I and see if the element to the left of it, I minus 1, is larger. And if so, we need to swap those elements to get them in the correct order. And again, change the swap flag to true to indicate that a swap did occur. And after the array is fully sorted, we want to return that array. Let's move on to writing our code. So the first step is to initialize a variable. We'll call it const. And the variable, let's title it length, because we're trying to get the length of the array called items. So it'll be items.length. Next, we'll initialize a variable called swapped. So we'll say let swapped. We will set this to true. We're initializing it to true, and we will change that within the loop. We'll move on to our while loop. So while swapped, which indicates that swaps are still occurring in our passes, and that indicates that the array is still unsorted. Let's move our curly brace to the bottom here above our return. We want to change our flag status. So swapped will equal false now, because that's the default we want before we begin our iterations through the array. Next, we'll create our for loop that will go from left to right. We're going to let this variable be named I, and it will start at index 0. We want I to go up but be less than the length of the array minus 1. And we want it to iterate incrementally. I'm going to take this curly brace Move it down here. Next, we want to check if I is greater than the element next to it. So we're going to create our if statement here. If items at element I are greater than items at I plus 1, and again, I'm going to move my curly brace here. Then we will want to swap these elements, and we'll use our array destructuring again to do this. So we'll have items at I on the left to start with, and items at I plus 1 on the right, and we're going to switch the order of that on the right side of the formula. So items now at I plus 1 will be on the left, and items at element I will be on the right. We then want to toggle our flag from swapped equals false to swap equals true, indicating that a swap did occur. If no swaps occurred, we're going to have our if statement down here. So again, we're using that exclamation point to indicate no, it did not occur, no swap. Move my curly brace down here. If there's no swap, we want to exit the loop. So we'll put in a break. And if a swap had occurred, we need to reset our flag for the next pass. So we'll turn it back to false. Now we want to start on our next for loop that's going to reverse directions from right to left. So we'll start here with for. And we're going to have the starting place of our variable be length minus 1, because we're starting at the end of the array. And in this case, we want to continue going, but be greater than the 0 index. So continue down to the left. And now we will decrement iteratively. I'm going to move this curly brace down here. And now we want to check if the element to the left is greater than I. So we'll start our if statement, and we'll check if the element at items I minus 1 first is greater than the element at items I. I'm going to move my curly brace again. And if so, we'll do our swap below. So we'll start with the I minus 1 element on the left, I on the right, and we'll switch that order so that I is on the left and I minus 1 on the right. Next, we'll want to toggle our swapped variable to true. And our final step is to return our sorted array. So we'll return items, and our code is complete. We have our function on line 1 titled cocktail sort that's taking in an array of items. We define the length of our array, and we create and initialize a variable called swapped that indicates whether or not a swap is occurring during the pass. We're setting this to true to start, and then we're creating our while loop. So what we're looking for is while swapping is occurring, we're changing this variable to false to begin with. We do our for loop beginning from left to right, and we're looking, oh, I see an error in here. It's good to check. Looking to see if items at element I are greater than I plus 1. There's another one, there we go. And if so, we're going to swap those. So I and I plus 1, we're going to swap the order. So I plus 1 is on the left and I is on the right. And then toggle the swapped variable to true. We'll set up an if statement that breaks us out of the code if no swapping occurs. And otherwise, we'll change swap back to false. Next, we have our for loop that will go the opposite direction from the end of the array, length minus 1, down to greater than 0. We'll check if I minus 1, so the element at the left, is greater than I on the right. If so, we'll swap those items, toggle swap to true, and at the end of all of this, we'll return a sorted array of items. Now let's break down the worst case time complexity of cocktail sort, which is going to be O of n squared. This happens when the array is completely unsorted and the algorithm needs to make as many comparisons and swaps as possible. First, we have the outer loop, the while swap loop, which is controlling how many times the algorithm scans the entire array. In the worst case, it's going to run O of n times, where n is the number of elements in the array. And on each iteration, it's going to reduce the range of unsorted elements from both ends. Next, inside the outer loop, we actually have two inner loops. We have one for the left to right pass and another for the right to left pass. Each of these inner loops is going to run O of n comparisons during each iteration of the outer loop. So I mentioned we have one outer loop and two inner loops. So you might be wondering, why isn't the big O notation here O of n cubed? And the reason is that the two inner loops aren't nested inside each other. They run one after another. So since the inner loops execute sequentially and not in a nested structure, we don't multiply their time complexities. Instead, we're going to combine the time complexity of the outer loop, which is O of n, with the inner loops, which together will run O of n times on every pass. As a result, the time complexity then becomes O of n from the outer loop times O of n from the inner loops, and that's what gives us the O of n squared. For the best case scenario where the array is already completely sorted, that would be an O of n. And again, if we look at our graph, the O of n squared is going to be quadratic and have a much steeper time complexity as the size of the array grows, whereas in the best case sorted scenario, the O of n will have a linear relationship. So to wrap things up, we've talked through the cocktail shaker sort algorithm and learned how it differs from bubble sort. While both of these algorithms work by comparing and swapping adjacent items, cocktail sort optimizes this process by sorting in both directions, first from left to right and then right to left. This is going to reduce the number of comparisons and swaps that are needed in each full iteration. And by allowing the smallest element to move to the front while the largest element is moving to the back, the cocktail sort can be more efficient than bubble sort in certain scenarios, especially when the array is already nearly sorted. We also explored how the algorithm performs using big O notation, and while cocktail sort and bubble sort share the same O of n squared worst case scenario, cocktail sort can achieve better performance with fewer passes in certain conditions. Thanks for watching. I hope this breakdown helped you understand how to implement and optimize the cocktail shaker sort in JavaScript.